Have you ever visited the United States from Europe, walked into a supermarket, and stopped in front of the refrigerated dairy aisle to find eggs sitting where they have never sat in any shop you have been in before? Cold, packaged in polystyrene cartons, stored with the yogurt and the orange juice. The same egg, as far as you can tell. The same oval shape, the same brown or white shell, the same contents. Just kept at a temperature that would be unusual in any European kitchen. Or the reverse, an American arriving in a British supermarket, finding eggs on a shelf in the ambient aisle between the bread and the pasta, and wondering whether someone in the supply chain has made a serious mistake. Unrefrigerated eggs feel, to an American who has grown up with refrigerated ones, faintly dangerous, like something left out accidentally that should have been put away hours ago. Both groups of shoppers are behaving entirely rationally. Both are applying food safety knowledge that is accurate and complete for the system they grew up in. The egg they are each looking at is, biologically, identical. But the egg they are each looking at has been processed in fundamentally different ways before it reached the shelf. And those processing differences make the two eggs behave differently, require different storage conditions, and create a situation where the safe thing to do in one country is the unsafe thing to do in the other. But here's the surprising truth. The difference is not about the egg. It is about a decision made at the level of industrial food regulation, with two entirely opposite philosophies about where in the supply chain bacterial risk should be managed, each one internally consistent, each one creating a system that works reliably within its own logic and fails dangerously when applied to the other. Today, we're unpacking what each system actually does to an egg before it reaches the consumer, why the same action that makes eggs safe in America makes them unsafe if handled the European way, and what a thin, invisible layer of protein on the surface of an eggshell has to do with all of it. To understand this properly, you have to begin not in a supermarket, but on the surface of a freshly laid egg. An eggshell is not a sealed container. Under magnification, it is covered with thousands of tiny pores, necessary for gas exchange during incubation, through which bacteria can pass in either direction if conditions allow. A freshly laid egg is protected from bacterial ingress by a thin coating of proteins and glycoproteins deposited on the shell surface during laying. This coating, called the cuticle or bloom, acts as a natural sealant over the shell pores. It does not eliminate the possibility of bacterial contamination, but it significantly reduces the rate at which bacteria can penetrate the shell and reach the interior. An egg with its cuticle intact, stored at consistent ambient temperature and handled without extremes of heat, has a meaningful natural barrier between its contents and the outside world. Both the American and European systems begin with this same egg. What diverges is what happens next. European regulations, shaped by food safety philosophy that emphasizes preventing bacterial contamination from entering the food supply in the first place, prohibit the washing of eggs before sale. The cuticle is left intact. An unwashed egg retains its natural barrier, which means it does not require refrigeration to remain safe at typical ambient temperatures for a reasonable shelf life. The regulatory system makes this trade, except that occasional individual eggs may carry surface contamination in exchange for maintaining the cuticle's protective function across the entire supply. Think of it like a raincoat. The coat keeps you dry as long as it is intact. The moment you put it through an industrial washing process that strips the waterproofing from the fabric, you need to find another way to stay dry. The cuticle is the raincoat. Washing removes it. Once it is gone, the egg needs a different form of protection. The American system strips the coat and provides that different protection. United States Department of Agriculture regulations require that eggs sold commercially be washed and sanitized before sale, using water, detergent, and in some cases a light chlorine rinse at temperatures high enough to open the shell pores and allow the cleaning agents to reach the surface bacteria. The process is highly effective at removing surface contamination, including salmonella present on the shell exterior. But it also removes the cuticle entirely. A washed egg is cleaner on its surface than an unwashed one. It is also more vulnerable to subsequent bacterial ingress because the physical barrier that would have resisted penetration is gone. A washed egg stored at ambient temperature will absorb bacteria from the surrounding air and any surface it contacts at a rate that an unwashed egg would not. Refrigeration suppresses bacterial growth sufficiently to compensate for the lost cuticle, extending safe shelf life by keeping the egg cold enough that any bacteria present reproduce too slowly to reach dangerous levels before consumption. So, if each system works reliably within its own logic, what happens when the two systems collide? The answer, as is often the case in history, comes down to what happens when an egg designed for one system is handled according to the other. An American washed egg taken out of refrigeration and left at room temperature for several days is genuinely higher risk than an equivalent European unwashed egg stored the same way, because the American egg has lost the protection that makes ambient storage safe. The European egg left in a refrigerator is not dangerous, but the temperature cycling that occurs when a refrigerated egg is brought to room temperature, used partially, and refrigerated again creates condensation on the shell surface that can carry surface bacteria into the pores more readily than stable ambient storage would. The recommendation in each country, refrigerate always or never refrigerate, is not arbitrary caution. It is the correct instruction for the specific egg that country's system produces. The regulatory divergence has its own history. American commercial egg washing became standard practice through the mid-20th century as the scale of industrial poultry farming increased and the concentration of production made surface contamination a more significant statistical risk at the population level. Washing provided a reliably measurable reduction in contamination that suited a regulatory culture oriented toward quantifiable industrial standards. European regulators, faced with the same underlying risk but operating within a different regulatory tradition, chose to address it at the flock level through vaccination programs against salmonella in laying hens, reducing the probability that contamination would be present on the shell in the first place, rather than removing it after the fact. Both approaches reduced the risk. Neither approach was obviously superior. Each embedded itself in the regulatory infrastructure of its region and created a supply chain that now depends on its continuation. Switching systems is not straightforward. An American producer who stopped washing eggs would need to demonstrate that cuticle-intact eggs could be safely distributed through a cold chain infrastructure designed around washed eggs, and regulators accustomed to measurable washing standards would need new frameworks for verifying safety. A European producer who began washing eggs would immediately be required to refrigerate them, adding cold chain costs to a supply chain not currently built for them. The systems are self-reinforcing, not because either regulator is resistant to evidence, but because changing one element requires changing many others simultaneously. So, the next time you travel between continents and find eggs somewhere unexpected, in a cold case or on an ambient shelf, you will know that neither system is careless. Each egg has been processed according to a coherent philosophy about where in the production chain bacterial risk is best controlled, and the storage instruction on the carton is the correct instruction for what that processing left behind. The egg looks the same. The invisible decision made before it reached the shelf is entirely different. Safe handling begins not at the shop, but at the decision about whether to remove what the hen already put there.